Good afternoon, good people. My name is Hendrik Makaneta, and today we are proceeding with our lesson on mathematics grade 7. And of course, what is important is that we must just focus because this lesson will be based on the, it will be a continuation of from the previous lesson that we had last week, and it becomes important that prior knowledge on the work that we've done is utilized in order to understand exactly what is happening in today's lesson. And of course, as I've already indicated, this is grade 7. And of course, yes, everything is under control there. This is grade 7 maths. And of course, those of you who may want to reach me after this lesson on the Twitter account at Hendrik Makane3, that is where we can further engage if you have got further questions regarding today's lesson. And I hope that it will be as exciting as the previous lessons. And of course, the objective of this lesson at the end of this day, or at the end of this 1 hour or 45 minutes rather, we must be able to use the appropriate formulae to calculate the perimeter and the area of triangles. You will recall that we worked with the area and the perimeter of both the square and the rectangle in our previous lesson. And we were able to define the formulae, and we said that the formula to calculate the area of the square, you'll have to multiply the length by the length, and to calculate the area for the rectangle, the area there is given by the formula A is equal to L times B, that is the length times breadth. And what is happening now? We need to now carry on with our area for the triangles. And I'm going to build this up from the previous knowledge that you have of calculating the area of a rectangle. So let us start with the area of a rectangle. But just to recap, we also spoke about the perimeter of a polygon. And we said that that is the sum of the lengths of the sides or the distance along the edge of the shape. And what is important is that, the perimeter, nothing has changed in as far as the perimeter is concerned. What we need to do is to remember that the perimeter stays the same, and that will be the distance around the edge of the shape. And of course, all regular polygons and irregular polygons, the distance is the same. The perimeter is the same. If I can just show you, we also used a conversion, square millimeters to square centimeters. I'm not going to focus a lot on the conversion today, as you know that the purpose of today's lesson will be to calculate the area of a triangle. And how would you calculate the area of a triangle? This can be shown in the next slide, but you are going to need half of the base multiplied by what we call the perpendicular height. Now, if you take the following example, how do you derive the formula for determining the area of a triangle? How are we going to determine the area of a triangle? Very simple. Very, very simple. We do this by using the formula for determining the area of a rectangle. So you will see from this example that it will be easier for you to derive the formula to calculate the area of a triangle, now that you know the area for the rectangle. And just to recap, we said that the area of a rectangle is equal to length times breadth. So let's do the following activity. Let's go to step 1. Let us draw a rectangle ABCD with the length of 5 centimeters and the breadth of 3 centimeters. Thereafter, go to step 2. I'm sure it should be easy for any one of you now to draw the rectangle ABCD using the measurements that I've just shown you there, meaning that your length or the length of your rectangle should be 5 centimeters and the breadth should be 3 centimeters. Now, once you have done this, now you can draw the diagonal. I'm sure that we all know what a diagonal is. I'm not going to define a diagonal today, but of course a diagonal is that line that joins the 2 points of your rectangle. I'm sure you'll see it as we proceed in the next slide, where we will be able to draw your diagonal. Now, that is step 2. And then, of course, step number 3, you are now going to name the polygons. Now that you have drawn the diagonal, you will name the polygons that are found there or which are formed. The first one will be ABC and the second one will be triangle ADC, meaning that you have divided your rectangle into two polygons, which are triangles. And step number 4, you will determine the area then of the rectangle. Thereafter, with the step 5, you'll determine the area of the 2 polygons which are formed. I'm sure that it should be able to make sense now. Let's carry on. Remember, what is the purpose of this exercise? We want to derive the formula to determine the area of a triangle. So we're not going to assume that you know the area for the calculating the area of the rectangle, or the formula rather. So we assume at this stage that you do not know what the area of a triangle is, and we are going to show you how to determine that area. Every learner who is in this class today, who was here also last week, will remember that we have taught you how to find the area of a rectangle. So you are going to use that knowledge, the knowledge of finding the area of the rectangle. You will use that knowledge now to derive the formula for the triangle, for the area of a triangle. And of course, there are 4 steps there, in fact 5. You will have to use step 1, as I've said, draw the rectangle. I hope many of you have already drawn that. You have drawn a rectangle by now, which is a rectangle ABCD. And once you are still there, you mention the length. The length must be 5 centimeters and the breadth must be 3 centimeters. And again, you draw the diagonal AC, and thereafter you name the polygons which are formed. Once you draw the diagonal, you will see that you have divided now your rectangle into 2. If you have cut it into 2 equal parts, that will be the first one, triangle ABC, and triangle ADC. That will be your 2 triangles. And at this point, what do you do? At this point now, you can determine the area of the rectangle, which you know by now. The area of the rectangle you know, and that is defined by length times breadth. So in this case, it means that your area will be 5 times 3, because your length is 5 and your breadth is 3. So that will be 5 times 3, which is 15. So let's go and look at the formula now, at the diagram that we have drawn from step 1 up to step 5. So you should be able to come up with this particular diagram. As you can see, there are two diagrams there. The first one is not yet cut into two. The first one is still a solid rectangle. And note, when A and C are joined, it creates two triangles that are equal in area. In other words, the area for triangle ABC will be equal to the area for triangle ADC. Now, that is the first triangle, the rectangle that you see there. And look at the second part. Now, the second part, what have we done? We have now divided our rectangle. In other words, we've cut it into two equal parts or equal polygons. Now, we no longer have a rectangle, but we've got now two triangles. And you can see that the length has not changed, which is now the base of the triangle there. And of course, the other one, the breadth, has also not changed, which has now become the height of the triangle. So you can see that in the triangle ADC, we now have the height and the base. So where does the base come from? It is your length, which is 5 centimeters. Where does the height come from? It is still the same breadth there, which you had before. Now, at this point, we can use the knowledge that we have of calculating the area of a rectangle. And of course, it should be able to give us 15 square centimeters, because we know that length times breadth is the area of a rectangle. And of course, the length is 5, the breadth is 3. Thereafter, you are done with the area of a rectangle, which you know by now. But how will you know what the area of the triangle is? Obviously, if you have got 15, if you have got 5 times 15, then it means one of the areas there of the triangle will be 7,5 centimeters, square centimeters. Well, how do you find it? It means you divide now 15 by 2, because then that will be half of the triangle is half of the rectangle. Or you can simply say half of 15. Half of 15 is 7,5 square centimeters. So you can see that it means that each triangle will have the area of 7,5 square meters. That is what you'll have. But how do you do it in practical terms? In practical terms, we can see that we have now defined the area of the rectangle ABCD, and we have said that that area is length times breadth. And of course, the length times breadth, it's something that we know, and we know L times B gives you 15. But what will be the area of triangle ABC or triangle ADC? It means it will be half of the area of the rectangle. So in other words, it will be half of the length times the breadth. And of course, in rectangle ABCD, we know that AD is the length and CD is the breadth. And look at triangle ADC. Can you see that AD is the height and CD is the base? It was put around. Initially, we had said that AD is the base, and then, of course, DC is the height. Well, that depends on how you look at it. If you turn your triangle 90 degrees, if you rotate it, clockwise, in the clockwise direction, I'm talking about triangle ADC. If you turn this triangle and rotate it clockwise, not anti-clockwise, but clockwise. If you rotate it once using 90 degrees, you will see that the height now becomes AD. Your AD becomes the height of the triangle. And of course, GC becomes the base. Now you can simply substitute. Because remember, we said that the area of a triangle ABC or ADC is half of the length times the breadth. So meaning that you can simply substitute. And of course, once you substitute, you'll have the base and the height. So hence, the area of a triangle will be half of the base times the height of the triangle. So this is how you derive the formula to calculate the area of a rectangle. It should be clear at this point that we have now derived the formula to calculate the area of the triangle. And of course, this is what we have there. In as far as this slide is concerned, we have now managed to calculate the area for the triangle, which is half a base times height. That's how you find the area of a triangle. And we should be able to use this as and when we carry on with our activities. I'm not going to waste a lot of time. I hope that to wrap up this lesson, you have seen what we have done. We've followed about 4 steps. We said that the first step is that you draw the rectangle. That is the first step that you need to follow. And thereafter, you have the length, which is 5 centimeters, and the breadth, which is 3 centimeters. And thereafter, you draw the diagonal. Once you have drawn the diagonal, you can now name the polygons which are formed. And in this case, you will have 2 equal triangles, triangle ABC and triangle ADC. And of course, you can now determine the area of the rectangle. And once you have determined the area of that rectangle, something that you know from the previous lesson, you can now determine the area of 2 polygons which are formed. Those are triangle ABC and triangle ADC. And you can see once again, we have spoken about this. You will be able to see now that once you have joined A and C, it creates 2 triangles that are equal in area. Triangle ABC and triangle ADC. How do we know that they are equal? Because each triangle has got the same length. Remember, the rectangle has got 2 equal sides. The length of a rectangle are equal, both lengths, and it also has the same pair of breadths that are equal. So that's how we know now that triangle ABC is equal to triangle ADC. And of course, to derive the area of a triangle, there's no other way in which you can derive it without relying on the area of a rectangle. And we know by now that the area of a rectangle is length times breadth. That is something that we have learned about last week. And of course, the area of a triangle there, it will be half of the area of a rectangle. So meaning that, why is it half? Because half of that triangle, half of the rectangle gives you a triangle. That is why even the area of the triangle will be half the area of the rectangle. And of course, half of length times breadth. And as you can see, we have said that once you rotate your triangle ADC 90 degrees clockwise, meaning that you just turn it. You just turn it once. Even with the hand, if you were to turn the triangle, you turn it once, and so that you can see your height. But even if you don't turn it, you should be able to see that your height there it's AD, and your base becomes a DC. And of course, this becomes half a base times height. And this, as we have indicated, is the area of a triangle. So now at this point we have done the area of a square. We know the area of a square, which is length times length. We also know the area of a rectangle, which is length times breadth. Today we have learned about the area of a triangle, which is half a base times height. So half a base times height, or half of the base times height, half of B, where the B stands for the base and H stands for the height. So we now know how to calculate the areas of those polygons, the square, the rectangle, and the triangle. So up to this point, this is how we finalize our lesson in as far as how to derive the area is concerned. So now what we're going to do is to apply this knowledge. Now that we have learned how to find the area of a triangle, we are going to apply that now in various examples. Now, you can look at the height of a triangle. It must be a perpendicular line segment which is drawn from a vertex to its opposite. The height of a triangle is a perpendicular line. What do we mean by a perpendicular line? It means that line forms 90 degrees. When you join it with the base, the angle that is formed there must always be 90 degrees. Now, the sketches that are shown below show different positions of the heights in triangles. So the heights won't always be in the same, drawn in the same position. You can see the first one there, we've got triangle KLJ. And of course, your height there is JM. That is your height, and your base is KL. I'm talking about the first triangle. You can see that we have drawn a line from J, which will be perpendicular to the line KL. And since this is perpendicular, you can see we have got now a new point, which is outside of the triangle, but of course it is horizontally on the same line with KL. And this gives us the base, which is KL, and the height now will be JM. That will be the height of the first triangle. And of course, the second triangle there, you can see again, we have KM, which is the height. We have drawn a line from the vertex, which is perpendicular to the base, and the base in this case is JL. As I've indicated, you don't really have to rotate it, but if you rotate your triangle, you'll be able to see that your base is JL, but you don't always have to do that. Even by inspection, you can tell that the base of the triangle will be JL, because that is where you are able to draw now another line. So you can draw a perpendicular line in different ways. The first one was JM. The second one there is KM. So look at the third one. The third one, you can draw a line from L, which goes to a point M. And of course, JK now becomes your base and LM becomes your height. Now, these are three different ways in which you can draw your height. But remember, it's not just a height. This is what we call a perpendicular height. So the height of this triangle must be a perpendicular line segment which is drawn from the vertex to its opposite. And you can be able to use that to now calculate the area. Now that you know different heights drawn from the vertex, we can proceed now to do an example. And of course, let's go to this example. Before we carry on with the area, I just want to remind you again that when you calculate the perimeter of a triangle, you use the same method that you've used in the past. In other words, you can simply add all the sides together, like as it is shown in this example here. This is example 2. It should have been example 1, I believe. So it's example 2, but example 1 will follow now. You can apply this definition of a perimeter. And of course, the triangle shown has got 3 sides, S1, S2, and S3. If you add them together, they will give you a perimeter of a triangle. Then we are now moving to the core function of today's lesson, where we are going to now use the area of a triangle. Now look at this example 1. Consider the following triangle. Calculate the perimeter, that's the first thing. Secondly, calculate the area. Now you can see you are given a base, which is 10 centimeters. You are also given a perpendicular height, which is 12 centimeters. You also have other sides. Now, to calculate the perimeter, obviously you must work with the original triangle, which has got only 3 sides. And those sides, the first one there is 10 centimeters, which is the base, followed by 13 centimeters, followed by 19 centimeters. And of course, you should be able to find now the perimeter of that triangle. But to calculate the area, you will now have to consider half a base times height. Now let's look at our solution. Of course, you add your 10 centimeters plus 13 plus 19, as I've said. And this will give you 42 centimeters. That is the perimeter of the triangle. And of course, to come to the area, we have defined the area as half a base times height. So it's half of the base times height. And this will be half of. We have already agreed now that the base is 10 centimeters, as you can see in the picture, and the height is 12. And 10 times 12 is 120. 120 divided by 2 gives you 60 square meters. So we have been able to now find our answer in as far as the perimeter and the area are concerned. Just to take you back, the example says the base, again, it's 10 there. So half a base is half of 10, which is 5, times the perpendicular height, which is 12. And of course, if you multiply 10 by 12, you get 120. And of course, if you divide 120 by 2, you get 60 square meters. This is how you calculate the area of a triangle using the formula that we have just derived not so long ago in our lesson. Now, having defined the area and having calculated the area of this triangle together with its perimeter, we can proceed to make the following conclusion: that the perimeter is the distance around the edge of the shape, and that the area of the triangle is just half of the base multiplied by the height. Let's look at another example. In example 3 here, you are now given a different example altogether. Now you have got triangle ABC. You are given the area, which is 48 square meters, and the perpendicular height is given as 16 meters. So now you are given the height. You are given the height of the triangle together with the area What is it that you must look for now? Find the length of the base. So you need to find the length. So at times, you will not always be required to calculate the area. At times, you may be given the area and you may be told, or you may be asked or requested to find one of the sides. It could be the height or the base. Now, in this case, you are given the height. You are also given the area. This means that you need to find now the base. Again, you use the same area, the area of the triangle, which is half a base times height. And of course, that is the area. Now you can substitute. This becomes half of. The base is your unknown, but the height is 16 meters. So you can simply substitute 16 for your height. And of course, your area there will be 48 square meters. And then you can substitute the area there as 48. And thereafter, we know half of 16, because remember, this is just one term inside the box there. Inside the brackets, because you are multiplying b times 16, so that's the product. So since they are not the same, one is a variable, another is a number, so you can work with numbers. The half of 16 is 8, and now you've got 8, and at this point you can divide now both sides, because you'll have 8b is equal to 48. Now if you divide both sides by 8, 48 divided by 8 gives you 6. So if you divide square meter with just a meter there, you get a meter, meaning that your answer will be B is equal to 6 meters. That will be your answer there. So this is the example that you can use where you are able to apply the knowledge that you have just gathered of calculating the area of a triangle. So in this case, you are given the area. In the previous example, you were not given the area. You were given the breadth or the base, in fact, and the height. So you had the base and the height in the previous example, hence you were able to find the area. At this point now, you are given the area together with the height, and you are expected now to find the base. And of course, we have found the base, and we have said that the base will be 6 meters. Just to recap, we have spoken now about a triangle here wherein you can be able to find the perimeter. And we said that the perimeter of this triangle is the distance around the edge, or yes, the edge of the shape. So meaning that you add only the sides. Only the sides. And once you have added them together, they will give you 42 centimeters. And of course, the same goes for the area, where you will use the formula, which is half of the base times height. And of course, your height there was 10 centimeters, and the height was 12, and you were able to find the solution. In this case, you are not given any base there. The only information that you have, you know that the area is 48 square meters. You also know that the height of that triangle is 16 meters. So what is important is that you don't have to see the triangle. Just to have information, it's enough. You don't always have to see the triangle in black and white, because what is important is the ability to recognize the information that is given. So without inspecting the triangle, you can already tell that your area is 48 square meters, which is given, and the height is also given. And of course, you use the formula. So this formula will be used throughout, not only in this grade 7, but throughout your study of mathematics. Even if you were to proceed to the next grade, in grade 8, you will still use the same formula. It doesn't change. It is just one formula. Even in grade 9, even in grade 12, even at university. So you'll use the same formula to calculate this area or the missing side. Now, we are coming to this activity here. I want us to use now the formula to calculate the area of triangle ABC. Now you can see in triangle ABC that you are given the base as well as the height. And we are informed that the base of this triangle, which is BC, is equal to 18 centimeters. And the height AD is 6 centimeters. And again, you can use the formula if you calculate the area of a triangle. And the area of the triangle is equal to half of the base. The bracket simply means off because you are multiplying there. Off means multiplication. Half of the base times the height. And as we have said, and as you can see in the picture there, the base BC is 18 centimeters. And what is the height? The height is, of course, 6 centimeters. That is AD. And this information is given to us. Now we can use the given information to just calculate. Now look at this activity. What is the difference between this activity and the previous ones? In this activity, from the previous one is that, you are not told that the height is AC, the height is 6. You are not told in a sentence. You can just see it on the sketch. It is there on the diagram. Again, you can see 18 centimeters is also there in the diagram. And then you can use that diagram to interpret it right into the formula. And of course, this will be half of 18 multiplied by 6. And of course, 18 times 6 gives you 108 square centimeters divided by 2 will give you 54 centimeters. So now your area, the area of triangle ABC will be 54 square centimeters. That will be the area. It will be 54 square centimeters, not just centimeters, but square centimeters. Remember, you're multiplying out the two. 18 centimeter times 6 centimeters gives you 108 square centimeters. And of course, this helps us to interpret or to use the formula to calculate the area. And as you can see, just to wrap up our lesson, we have said that the area of a triangle is given by the formula half into B times H. And this is your formula to calculate the triangle. And this is the formula that we derived in the beginning of this lesson. But equally, we have said that the perimeter of a triangle is equal to the sum of all the sides. In other words, side 1 plus side 2 plus side 3. This gives you the perimeter, which is the distance around the edge of the shape. Once you know these two conditions, the condition of calculating the area of a triangle and the perimeter, once you know under which conditions can you calculate the perimeter or the area, then you should be able to use the information in any activity that is given, even in the exam. The area of a triangle and the perimeter of a triangle. So up to this point, we have defined 3 polygons. We've looked at 3 polygons. The first one that we looked at was the square. And the second polygon was the rectangle. And the third one was the triangle. In each case, we have looked at the perimeter of a square, meaning that you add all 4 sides. We have also looked at the perimeter of the rectangle, where you also add all the 4 sides. And today, we've looked at the perimeter of a triangle, where you add the 3 sides together. In the same note, we've also looked at the area of the square, which is a length multiplied by length. We've also looked at the area of a rectangle, which is length multiplied by breadth. And today, we have looked at the area of a triangle, which is half of the base multiplied by the height. That is what we have looked at this particular afternoon. And what I want us to do now is to follow the following. This is the homework that I want to give you. Let's say you have got a triangle ABC, where the area of the triangle is 88 square meters, and you are required to find the length. So you are not just given the area. You are given the area, which is 88 square meters. You are also given the height. And this, by the way, is the perpendicular height, which is 8 meters. And you need to find now the length of the base. So the first things first, you need to draw the triangle, which is triangle ABC. And once you are still there, you must draw a perpendicular height, meaning that you need to join the vertex of your triangle, one of the vertex, with the base. And where they meet, where that line coming from the vertex meets with the base, they must form 90 degrees. And it is at this point that you can now apply the formula which you have learned today. And that is the formula to calculate the area. Remember, the formula to calculate the area, we have just spoken about it now. And we said that the area of a triangle is given by the formula half of the base multiplied by the height. So that will be half open bracket B times H. And of course, this should be enough to help you to find the missing side, which is the length of the triangle. And that we can look at tomorrow when we meet again. But of course, let us continue to use other helpful sites or helpful links, which can help us to follow you through with the work that we have done today. And of course, let me take this opportunity to invite you to our next lesson again, where we will carry on with the properties of 2D shapes. Until we meet again tomorrow, you can contact me on my number as well, 082 623-2148. You can send a WhatsApp message just to ask questions if you can. Please follow us on the social media links at Africa Teen Geeks. That's our Twitter account. And of course on Facebook as well. Just search for Africa Teen Geeks. And this lesson is provided in partnership with our sponsors, Sasol Foundation. And of course, the DBE is there as well for further information. Until we meet again tomorrow at the same time, have a nice day.